Good morning. Let's talk about rational functions. Now, rational functions are really, think of it as a ratio. It's a ratio of two polynomials. And what that really means is you have a function, say f of x, and your function has variables in the numerator and variables in the denominator. All right. So in math up to this point, you're usually just dealing with variables in the numerator. Now we have to deal with variables in the numerator and denominator. And what happens is they create these graphs that have different pieces to them. Okay, and these pieces are created by things called horizontal and vertical asymptotes, which I'm sure you're familiar with. For example, a horizontal asymptote might look like this, and this functions as you get towards positive infinity. This function is approaching zero. We'll get closer and closer and closer to it, but we'll actually never touch it. Okay, so this is the parent function. Remember transformations, you had a parent function, and we're going to add a whole bunch of things into this to make it shift and expand and move horizontally and vertically and all those things. So, well, let's talk about just the graph of the parent function. Okay, I have a vertical asymptote, and I've already drawn in the horizontal asymptote. Where did these come from? Well, with all of these rational functions, finding the vertical asymptote is the easy part. Okay, because the rule's the same for each one. You're going to look at the denominator, and you're just trying to figure out when is the denominator. You have to excuse me, I don't write very well with a mouse. So you're trying to figure out when the denominator is equal to 0. More specifically, what value of x makes the denominator 0? Well, in this case, x is equal to 0. Well, for the function, x is not allowed to be equal to 0, but the line that we're drawing, the asymptote itself, is the vertical line x is equal to 0. Okay, so that's where this vertical asymptote comes from on our parent function. All right, the horizontal asymptote, there's going to be different rules for different situations. Okay, now over here, we have math speak, our math language, and really all this is saying is you're worried about the first term in the numerator and denominator, okay? And there's a coefficient and there's a degree. A coefficient and a degree. We're going to call the coefficient of the numerator A. We're going to call the coefficient of the numerator B. We're going to call the degree of the numerator N. And we're going to call the degree of the denominator M. All right. The first situation we want to look at is, well, when the degree of the numerator is less than the degree of the denominator. And that's what's happening here. Think of it, you might say, well, there is no degree here. Technically, there is an x here, but it's x to the 0 degree. And we know from our exponent properties, anything to the 0 degree is 1. So 1 times 1, so we just, with a constant, we don't show the x to the 0. Anyway, this is kind of small math fact that we don't talk about very much. That degree of this is really 0. The degree of this down here is 1. Okay, so for this situation, the degree of the numerator is less than the degree of the denominator. If that's the case, basically the rule is if the degree of the numerator is less than the degree of the denominator, you have a horizontal asymptote at y is equal to 0. Okay, and that's where this horizontal asymptote here is coming from. Okay, so vertical asymptote was where the denominator equals 0, and the horizontal asymptote is at y is equal to 0. All right, the second graph I have here, okay, this one here, this came from the function. Here, let's clean this up a little so we have some room. We'll call this function g of x. Remember, g is just a name. I can name it anything I want. So g of x on this one, I believe, was 5 over x minus 1. Okay, so to graph this, we're looking for the vertical asymptote. What makes the denominator 0? Well, a value of 1. So for this one, our vertical asymptote has shifted. Let's check our degree. Degree of the numerator is 0. Degree of the denominator is 1. So we have this situation, n is less than m. We know in that case that then our horizontal asymptote is the line y is equal to 0. Okay, so to graph our function, we'll talk about other things such as y-intercepts and x-intercepts. We'll talk about those a little bit later. So for now, if you were to graph this, basically you're going to do an input-output table. Okay, you're going to select a value for x, and you're going to figure out what the values of y for, and then you just get your graph. Okay, and I'll be making another video here to talk about the other two situations for our horizontal asymptotes. All right, talk to you soon.